Okay guys, so here we are, recording on my new phone, which seems to be a heck of a lot better than the old one. Should be pretty good for you guys. So I wanted to talk about some stuff here. Now, the Chinese do things a little differently engineering-wise than we do here in North America. For example, if you see this sticker on something like this, it's telling you the voltage of the board. This might say a crazy high voltage, but 12 volts is labeled on it. Well, why would that be? It's clearly not the voltage of this, so it must be the voltage of this, right? Well, that would be the typical method that we would do here in North America. You would have the voltage of the board, but the voltage of the capacitor is often very different than the voltage of the board. So it's common for them to say on the capacitor that says 63 volts to put the voltage of the board. So here is a BMS, and you'll notice that it only goes up to 5 cells. Well, that's not enough. That is for a 12 volt system. Now, originally I thought this was going to be 12 volts. In the pictures, you could see this, and I thought it was 12 volts. It was the cheapest one I could find, and they come in 12 to 24, 24 to 36, and 36 to 38 volt. All of that led me to believe this was the cheapie. Turned out I got a good deal, and it wasn't. It's actually 24 to 36 volt, but that kind of screwed up my plans. One, it makes my BMS useless. I'll explain why. So when it says 12 to 24 volts, you actually get a nice cell variance range there. But what that means is it's 12 volt minimum, which means the board has an auto shut off. So if it goes below that voltage, it'll cut it. So let's say you build a pack that's only 12 volts. It's only got 3 cells in it instead of my 7 over here. When you look at a 3-cell pack, okay, that's great. It takes up a tiny little space. Maybe you can put 4 of them together and rig it for great runtime. But in the end, you're only running 12 plus volts, maybe 13 or 14 or 16 volts. And when you, at full charge, and when you run it down, it'll die very quickly and go below that 12 volts. That's bad. That's not going to give you much runtime. But I was expecting that and was going to show you guys how to use a boost method that I know to amplify your amperage before it hits the motor after it leaves the board, so it doesn't put extra drain on the battery but gives you a lot more power at the wheel out of the same current, which is really good because it'll give you a lot more runtime. But some things happened right away when I bought this that kind of interfered and screwed things up, and it led to a lot of videos being shot. Unfortunately, they are now lost. I recommend you not encrypt your SD card because you won't be able to swap it. One, this was incorrectly done. When you look here, underneath this connector, it clearly shows the power right here, and you can see it right here. It's printed, right there. You can see a bit of printing underneath. Well, I'm not going to bother to pull it out, but rest assured, it is labeled where the positive and negative need to be, and these 2 yellow wires are a ground wire and an LED light. So the LED light goes to this green LED, which is green and red. And when I first got the board, nothing worked. I checked a whole bunch of stuff. I tried a whole bunch of stuff. Nothing worked. I shot videos on how nothing worked and what I was going to do about it. And what I ended up doing was bypassing the on-off switch. It's an easy symptom to solve when you have a broken on-off switch. So a lot of them come with crap off on-off switches. You just replace it or toss it. In my case, I just elected to toss it, but it brings up a whole bunch of things. For one, I bought the cheap board figuring I got the 12 volt setup. So I bought the 12 volt BMS, only this is no longer the right one because I actually got a good deal. And this is a 24 to 36 volt pack. Now with 24 to 36 volt, this is a very common size. And I wanted to cover this size specifically. So I have a 7-cell pack, and you can see when you look at the board, there is a spot for the battery management system to be connected, and I will show it to you, but I wanted you to take a good look at this board because you don't see a whole lot of labeling, but the important bits are actually there. So we're going to zoom right in on this. Whoa, not that much, folks. Sorry about that. New phone, very, very good zoom. All right, so here we go. You can see right here, it clearly says 6S and 7S. Now you might wonder, with a voltage range that big, why it would only be 2 cells, because it takes 3 cells to make 12 volts, right? So why isn't it 6, 7, and 8? And the reality is, if you go with the extra cell, you will be overvolting it very quickly, because the 36 volts isn't a nominal rating for a nominal pack. Like a 36 volt pack has a nominal rating of 36 volts. That's minimum. If it goes below that, you throw it out. This is not the same thing. So as what we're looking for, we don't want that. We want its maximum voltage has to be 36, which means you don't want the extra cell. So it's only 2 cells difference, 6 cell or 7 cell. That's the only options here. So I could have pulled 1 cell out of here, but instead I've done a 7 cell setup, and I want to show you a little bit about that and why. Unfortunately, this video is going to be a bit longer than usual, and that's why I have to show you all this stuff. Now, what I've done is to set this up in a jig, add the solder, then put the nickel on top of it, heat it until it collapses and they compress together, hold it in place with a foreign object, in this case a screwdriver, while I let it cool, and then just go along to each one. If you don't have a proper jig, they will come out a little messy this way, but they will work, and you'll get nice solid welds. I recommend if you're going to do that, you use this type where it's got the little slit down the middle, and that way you can put solder directly under it, and when you touch your soldering iron to it, it'll get good contact, remelt the solder, push the nickel strip down onto it, and then hold it in place when you let it cool. And you do 1 cell at a time. And if you do it this way, you can do it very quickly, because what I do is I load these with solder first, not on the battery, on the connector, and then put the whole thing together and melt it into place. Now, it didn't come out nice and neat, but it did come out very functional. And a lot of people have trouble making batteries. This is a good method for DIYing your own. Also, you'll notice I didn't connect it all the way at the end. And there's a reason I didn't do that, and it goes like this. It's all about current flow and where I want the flow to come from. So normally, if I put my connector at this end, it's got to go through all of these and draws off all of them, but it draws off the first battery first. Okay, well, in this setup, it draws off the first 4 batteries pretty equally, and then it has only 3 batteries outside of that. The majority of the pack is available to this setup right away. As soon as I apply a draw, it will draw from the whole pack very evenly. This is one way to not use a BMS, but to do it without wrecking your batteries, is not to have the connector at the end. A lot of people don't think of that. But if you put the connector in the middle, regardless of the cell count, this would work with a 6 cell or a 7 cell or an 8 cell or whatever pack, and you put your connectors in the middle. See how I've done this, where there's a connector across the middle that is in fact 2 nickel strips welded together, and then we have these guys soldered onto the outside of that, which forces these 4 cells to be drawn on very equally, which means the majority of the pack is under very equal draw. And these cells can add their power in very quickly and very readily, which allows the whole pack to draw off itself very equally. Believe it or not, this is a great setup for that. This is a more efficient layout than your typical pack, and I can recommend it. Now, moving on, we have pretty much now covered all the major stuff, but I wanted to show you something else. Now, this is a 36 volt maximum system, which means we're not going to be running any more than 36 volt into it, and yet I'm running a 48 volt charger, and you might wonder why that would be, but the reason is that I actually want it to be a pretty good charge. I want to get, see this, 42 volt? It's not technically 48 at 2 amp. Well, that is perfect for charging this guy. I bought this for the electric skateboard. I bought this, and they all fit perfectly together. This is the right enclosure, by the way, for this. If you guys are going to buy this type of setup, this is the enclosure you want. Don't go with any of the other ones. It is designed to fit this exact board. This one looks like it would be, but it's not. It doesn't actually fit this board very well. This one does. And also all of the accoutrements that come with this. There's, as you can see here, there's a battery gauge that I've put up to the front of my board in a nice, neat little box. That's actually a nice little upgrade. I'll show you guys that in the future. But for now, I'm basically ready. Now, I could, through those contacts, bypass the BMS here. But I'm not going to do that. You might think, well, I actually am. I'm going to bypass the BMS altogether because I have a setup that will help run the batteries a little better. Also, the strongest battery is at the end. I keep my strongest batteries at the end, the weaker batteries in the middle. It draws off these first, but they push a stronger charge, And so it'll help to force all these to take power really equally. If you have uneven cells, this is a great way to do it. Put your connector in the middle. Put the power to the outside, the most powerful batteries. Your weaker ones inside, your connector across the weaker ones, and your connection to your battery right in the middle. And you'll find that it's drawing off these four very equally, and these two are pushing in very equally because they have the higher power to be able to push through. And it works very, very well. And because of that, I am going to bypass the BMS. But I did originally buy one. I was planning on using one. They say it's an option for this board. You'll be warned. You will need one, or you'll need to bypass it. It's easy to bypass. I've already showed you how in other videos. Just connect those two. That's it. That's all. You take a little wire and you run it to whichever one applies to you. If you're running 7S, which I am, you'll see these bottom two will be connected here. That being said, I'll do the next video when I get the chance. Sorry about this. It's taken a long time. I've built all this up. I've got pieces built. I painted it. I had it all done pretty much. Only when I got it together, it didn't work and I had to tear it all apart again. It's one of the reasons I like to do a video series like this. It helps you guys to sort out the mistakes that you could make. And in my case, I didn't actually technically make any. What happened was this was miswired from the factory. In fact, this whole connector was reversed. Even though the keys for that connector were going the correct direction. They plugged it in right. It's just that it was all reverse connected. That being said, I don't know if there's anything else wrong yet. I won't find out until I bypass the BMS. I wanted to wait until I got a new phone. Today I got my phone up and running, so here we go. This is my skateboard as it sits so far. Battery pack is ready. Charger is ready. This will be a good quick charger for this. Not crazy fast, but it'll be better than a trickle charge. It'll get me decent charge times. What you want to see here is you want to have a higher voltage of charge than you're going to have at max voltage. My PAX is going to have a max voltage of 36. It'll be around 34 volts. This gives me a really nice voltage over that and a nice amperage to push a charge, which means I'll be able to push nice strong charge into this fairly quickly. That being said, this one's done. I apologize again for the long video. Originally I had done one video on each subject, including your cell selection and all that stuff. I basically just went through it really briefly with you right here. You have to charge your cells and then measure the amperage. You might think, no, just measure the voltages. The closer the voltages are, the better. You take all your middle, basically your weakest middle ones and put them together in the middle. Put your strongest ones on the outside and you'll find it actually works really good, especially if you're doing a 6-cell pack like this, because you can separate at the 3 mark for your mid section, but it's awkward with this type of fixture. And if you're going to use these quad fixtures, this is the best way you could configure those that I know of. That being said, I'm going to cut out for this one. Hopefully everything works. Hopefully everything is good. So far, the on-off switch was a problem. We've got a bypass that'll work. The next step is to bypass the BMS and then turn it on and see if it works with all those bypasses. If it does, I can dish away with this. If not, I'm going to have to buy another one. So I'm told it is an option and all you have to do is bypass it. So we'll soon find out. Enjoy the video series, guys. I am truly sorry that it didn't get uploaded, all of it, because I have some really good videos on this, on how to do it and how to build the box and make it truly waterproof and stand proof so you can stand on it in a whole ball of wax. It sits flush with my board on the back side but leans up just a tick so I can see it. In fact, it's quite visible running the board in forward or reverse. It's a really good location. Anyway, that's about it for this one. I will redo some of those videos, but I can't redo the one on how to build this little box because I'd be tearing it apart and that would damage my equipment, and I can't afford that, guys. I'm on welfare here. So I won't be doing that, but it's easy to do. A brief description goes like this. You take a piece of plexiglass as your back, you glue it to it. Before you do, you fill all the backside in with glue so it's all waterproofed. Then you glue it in place. Now you glue 2 sides, a back and a bottom and a top. Now you glue it to the inside of the board on a separate piece. So I built the box, glued it into the box, then turned it and did that and glued it all in place. And when you're done and you look at it from the other side, it actually looks quite good. And then I just painted it black and it's all good. So easy to do. The real trick is to waterproof it at each step and make sure that it's good and waterproof and use a lot of glue gun glue. That being said, that's it for this one. I also have built a full enclosure. I'll quickly show you some of the pieces here. Okay. These are our other pieces. One of them is the skid plate that goes on the bottom, like so. The others are intakes that grab air and direct it in, and then provide lips for water to get caught up on, so that water can pass through the bottom of it and all the air gets directed up to the top. It works really well. I'm not the only person on YouTube to have done it, but I did want to show it to you guys. Unfortunately, the videos have been lost, so I've got to reshoot everything. I will do that in this series. But officially, as of now, in this 15-minute video, you are caught up. So I'm just going to move forward from here because the build is really easy. There's nothing complicated here. This truck comes all as one piece with the motor, everything. There was no build. Literally plug it in and play. So, I mean, there's not much to show you there. What I am going to do is talk to you a little bit about the problems that I had as we go through this series and how I've solved each one. One of the problems was the connectors. No big deal. I bought E60s, so they're 60 amp capable. This is actually capable of putting out more amperage than that. They run 10 amp each, those cells. They're 9800s, and they run a little over their claimed number. Anyway, all being said, this is good. I'm happy, and I can't wait to share this with you guys in the future. Keith out.